So if we take a look, we have a warm-up. You got to classify each triangle by its sides. So the first one is equilateral. But we also can assume if it's equilateral, the angles are congruent. So we're also going to call this regular. That would be by angles and sides. Number two, we know that two sides are congruent, so that's isosceles. And number three, we know that all sides are different, so that is scalene. And number four, we're going to talk about finding the different angle measure. So number four, if you know two out of the three angles, we have 120, subtract that from 180, you get 60. And number five, in triangle DEF, if D is congruent to E and F is 26 degrees, what's the measures of D and E? Well, this equation would be that we have x plus x is equal to 26. What's the measures of D and E? Oh, I'm sorry. I think I read this wrong. One more time. We have D and E, so this is x and x. And angle F, so we have x plus 26 equals 180. So 2x, I'm going to subtract the 180 from both sides to get 154. And if I divide that in half, you get 77 degrees. So measures of D and F are both 77 degrees. So we're going to talk a little bit about vocab. You guys have already drawn this picture down a while ago when we started talking about isosceles triangles, but we already made a triangle. We labeled the congruent sides. These were called legs. These are the two congruent sides of an isosceles triangle. The base is the third side of an isosceles triangle, the non-congruent side. So that's a leg, this is a leg, then that means this is your base. And then we have a vertex angle. That's the angle, the third angle with legs as its two sides. So it's the third angle with the legs creating, let's say, legs as the two sides of the angle. So this up here would be your vertex angle. And then finally, we have your base angles. These are the two congruent angles opposite the legs. So here and here, these are called your base angles. Okay? Let's see. Just to talk about the theorem that we went over earlier, the base angles theorem. Base angles theorem says that if two sides congruent in an isosceles triangle then the opposite angles opposite the congruent sides are congruent. So it's just telling you in words the location of the base angles. And we've already done that in class earlier. And then the converse of the base angles theorem. The converse of the base angles theorem says, well, if two angles congruent in the isosceles triangle, remember we switch the hypothesis and conclusion to come up with converse. So in the base angles theorem, we said the two sides being congruent. So the converse says, well, what if the two angles are congruent? Then it just pretty much tells you where the congruent sides are. Then the sides opposite the congruent angles are congruent. Okay? So if I draw a little picture of the first one, it's saying you are given a picture and you're given the two congruent sides. Call this A, B, C. Then the theorem says you know that angle A is congruent to angle C because the angles opposite are congruent. So in the second converse, we can call these triangle ABC again. And it's saying if you know the base angles are congruent, then you know its opposite sides are congruent. So AB is congruent to CB. Okay. Those are the answers we just did. Okay. Here's the next one. Okay. So it says copy and complete the sentence. If you have HG congruent to HK, and you have to tell me which angles then are congruent. So let's go ahead and put those on our markings. Well, then you got to set, you can identify that angle G is congruent to angle HKG. I have an extra line coming from K, so that could technically be HKJ or HKG, so you have to be specific. Number 2, it says if KHJ, we'll do this one in green, KHJ, this angle, is congruent to KJH, this angle, then what can you conclude? We can conclude that the two sides are congruent, that HK is congruent to JK. That's what we can conclude. If we take a look at the next example, let's go ahead and finish this one. It says find the measures of angle X and Z. The only thing you know is angle Y, which is 50, but you know it's isosceles triangle, so the vertex angle is 50. You can use that information to find the base angles, because we know that this is X and that's X, so those have to be the same measure. So 180 is equal to 50 plus 2X. So I subtract 50, that's a 80. You get 130, we have to divide that by 2, and you get 65 degrees. Can an equilateral triangle have an angle of 61 degrees? No, it cannot, because each angle has to equal 60 degrees. So 180 divided by 3 is 60, not 61. And then if we take a look at our next example, it says solve for x and y in this triangle. One reason I picked this example in particular is because, as you can see, it gives you isosceles triangle. But if you pay really close attention to the vertex angle M, you'll see that there's a line coming down MO, a line segment MO, and it's cutting angle M in half. I wonder what that's called again. Angle bisector. Angle bisector! That's the one that cuts angles in half. So one note you might want to write down is only in isosceles triangles that also includes equilateral, because isosceles says 2, but if you have more than 2 congruent, more than 2 sides congruent, then it's also true for equilateral. Only an isosceles triangle is the angle bisector the same as a perpendicular bisector. It's the same segment. It's the same segment. So when you're solving for x, you automatically know x has to equal 90 degrees because an angle bisector means that it's also a perpendicular bisector, which makes 90-degree angles, so x is 90. And if we know x is 90, then we can go ahead and figure out what angle y is. Because base angles are congruent, we know angle n is 63 degrees, so 90 plus 63 is 153. And we can subtract that from 180. The easier way is I know that y plus 63 are complementary angles because in a right triangle, the acute angles have to add up to 90. So that means y is 27 degrees. And then finally, we have this nice lifeguard stand, their tower. And you're given that PS is congruent to QR and angle QPS is congruent to angle PQR. What congruence postulate can you use to prove that the triangles QPS and PQR are congruent? So what we do is we take a look at our markings. So QPS. So we have a side, we have an angle, and we have another side over here. And these look like they are corresponding to the other triangle so that we know the triangles are congruent by side angle side. Part B says, explain why triangle PQT, where is PQT? PQ and T is the middle point. So I'm going to highlight that in black over here. PQT, there you go. Why is it isosceles? Why is it isosceles? As you can take a look, we are given that angles 1 and 2 are congruent. We are given that angles 1 and 2 are congruent. So that means the triangles have to be, or the sides opposite have to be congruent. Angles 1 and 2 are congruent because of CPCTC. Because we showed that the two big triangles that are below the picture are congruent, then angle 1 is congruent to angle 2 by CPCTC. So triangle QPS is congruent, sorry, I was reading the wrong line. So triangle PQT is isosceles by converse of base angles theorem. So we had to use CPCTC to show we had congruent angles, and because I have congruent angles, the converse of base angles theorem shows that I have congruent sides. Okay? So that means that PT is congruent to QT by converse of base angles theorem. Write that down. And then it says show that angle PTS is congruent to triangle QTR. So I'm going to go ahead and delete or erase that and highlight the other one in this yellow color. So we have to show that this triangle and this triangle are congruent. Okay, so what we know is angles 3 and 4 are congruent by CPCTC. So we know angle 3 is congruent to angle 4 by CPCTC. And we know that this angle and this angle are congruent by vertical angles. This was T, S, R, Q, and P. We know that angle PTS is congruent to angle QTR by vertical angles, congruent. And then finally, I showed that vertical angles are congruent, these angles are congruent, and we already proved that PT and QT are congruent from question number, or part B. So we know that triangle PTS is congruent to triangle QTR by angle, side.